Hi everyone, welcome back to Geeks for Geeks practice. Please give me a +1 in the chat if my voice is clearly audible, and then we'll start with today's video as well and hit the like button. Let me quickly share my screen so that we can discuss the problem for today. Hi Naikaj and hi Rishit as well. So let's start with the problem discussion now. I think everyone has joined. All right. So okay. So please make sure to hit the like button, guys, if everyone is able to clearly hear my voice and everything is working fine. So today we are going to discuss this problem, that is BST, downward traversal. I think previously this problem must have been asked in some companies as well. Now, what does this problem say first of all? So we have been given a binary search tree. Okay. Now there is a property of a binary search tree, right? Now, what is the property of binary search tree? That if there is a particular node, so the left child will be lesser than the root node and the right child will have a value greater than the root node. The left child will have a value lesser than the root node, the right will have a value greater than the root node. Okay, now this problem says that I have been given a unique I have been given this BST with unique node values. Okay, so every node has a unique value inside it. Now I have been given a target value as well, and what we need to do is we need to find the nodes that like we need to first of all find that node which has the data same equal to the target. So let's quickly discuss this example so that we are more clear. Let me paste it here and then we can discuss this example. All right, so see, if we have been given this particular example right here, so in this particular example you can see that we have been given this particular tree. Now what we can do is, like, let's say we have been given the target and the target is nothing but 35. Okay, so if the target value here has been given to me as 35, so if the target is 35, so we have been given this particular node. If you will observe, so we have been given this particular node. If we have been given this particular node, so for this particular node, uh, just below it, okay, like inside, like when this is the target node, okay, this is my target node. Now which are all the nodes I have to take? I have to return the sum of all the nodes that are just below this target node. So which node is there? If I'll move down, so only 32 is here for this example, right? So please write 32 in the chat. Okay, so the answer here will be, the total sum here will be nothing but 32. Is that clear? Please write yes in the chat, guys. Is this point clear? This much point is clear to everyone? Please tell me and then I'll proceed further. Okay, so that is why the answer here is just 32, because whichever nodes are just below the target node, I have, like, whichever nodes are coming below the target node, vertically below the target node, all those I have to consider. Right, now let's check out the next test case as well so that we are more clear with the things. Right, so let's copy this image and see here as well. So let us talk about this test case. Now in this particular test case, if you will observe, so I have been given the target and the target is nothing but 25, right? So let's say the target has been given as 25. Now in this case, when the target is 25, so this particular node is there. Now which are the nodes that are lying just below it? Actually, when you will see, so these two are the nodes that are lying below it. Why? Because actually what happens when you will draw a tree normally, so let's say you have this, right, then you have this node, then you have this node. Okay, then this child, this node has this child, right child, left child. Let me draw it properly. So let's say this is having the right child here. Okay, this is having the left child here. So to be honest, what happens is these two are just below it, right? These two, this is also just below, this is also just below. Why? Because if you will give this as a numbering of 0, and if you are moving, let's say if you move to the left, then you'll decrease the numbering by 1. Okay, and if you are moving to the right, then you'll increase the numbering. So this will be -1, this would be 1. Okay, now from here you're moving to the left, so decrease the value by 1, so this will be -2. This will be what? If you're moving to the right from -1, then this will be 0. If you're moving from 1 to the left, so 1 minus 1 will be 0. And if you're moving to the right, so this will be 2. So basically these two are having the same position, these two are having 0 position, and this is also having 0 position. That is why if my target node has been given as 25, okay, so in that sense these two are the nodes that are coming below it. This is also having position 0, position 0, this was also having position 0, right? So if the target node is this, so all the, like, if the target node is this and the position of the target node is 0, right, so all the nodes below the target node which are having the position as 0, I have to consider them. Is that clear, guys? Please let me know. Is that clear? Please give me a +1, guys, if everyone is clear with this idea. Is everyone clear with this idea? Please hit the like button if you are clear with this idea, right? So basically, nodes that are below the target node having the same position, that I have to consider, right? So initially what I will do is I'll take the value as 0, let's say. Okay, and if I'm moving to the left, so I'll decrease the value by 1. If I'm moving to the right, so value will increase by 1. Similarly here, if I'm moving to the left, value decreases by 1. If I'm moving to the right, so value increases by 1. So this is the ideal concept. Now, what can I say here? The very first thing in this problem is that I need to run a recursive call. Okay, I need to run a recursive call, and I need to do what? I need to find. Okay, I need to find the target node inside this tree. Okay, inside this given BST, I need to find the target node. Okay, I need to find the target node in this BST, and once I found the target node in this BST, then after that I need to store its position also. Na? Is that clear? I need to store this target position as well. Is that clear to everyone? Please tell me. Is that clear? That I, first of all, I need to run a recursive call, or you can say I need to traverse the tree in such a manner that I am able to find out, I'm able to find out this target node, and once I find it out, then I'll store its position also. Okay, because if you will see here, so if this is having position 0, if this node is having the position as 0, right? So in that case, every node below it that is having the position as 0, all those nodes I have to consider. Is that clear? Guys, please hit the like button if everyone is clear till now. Is everyone clear till now? All right. So I hope that everyone is clear till now. So what will we do here? So we will simply run our recursive call, right? So initially we'll be starting, and what can we say? Suppose that if it happens that my current tree that has been given, so if the root is null, okay, so if I do not have any tree, so in such a case I can simply return what? I can simply return the answer, in such a case I can simply return what? In such a case I think I can simply return, let's say, -1, right? If the initial root is null, in that case I can simply return -1. Otherwise, what can I do? Otherwise I can say that, okay, let's call a recursive, let's start a recursive function. Okay, let's start a recursive traversal, and in that traversal I'll initially pass the root node. Okay, and I'll pass the target node as well, and I'll pass the value initially as 0, right? This is nothing but the position. You can say it as the position or the value, right? And I will also take a node, let's say node, let's declare a node outside. So let's say we have a node star, and let's say the target, let's say what? Let's say this target. So we'll store this target node over there. Okay, so initially, like, basically, when we'll get this target node, so basically, let's not declare it as target node. Let's say that it will be the start node. Okay, so what do I mean by that? Let's say that if I'm having a tree, let's say I have a tree like this. Okay, let's say we are having a tree which looks something like this. If we have a tree which is having this node, then we have this node, then we have this node. Let's say we have this node, then we have this node, we have this node, then 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 we have this node. Okay, now let's say it is having value 1, 5, 7 or something else, right? Now let's say the target has been given to me as 7. Okay, if the target has been given to me as 7, so this is the particular node that I'm thinking, right? And I'll start from here now. Like, this is the target node, so target value is this. Now I will say that, okay, this is the start node. Okay, I'll indicate it as the start node, because just below this node, all the nodes that are having the same position, I'll handle them. Is that clear to everyone? Please tell me, guys. Is that clear? So that is why I'll mark it as the starting point now, because see, once I will be able to find it, so once I will be able to find it, so I'll start the traversal from here. And then when I start the traversal from here, so basically all the nodes below this node that are having the same position, they will be considered. Is that clear to everyone? Guys, please tell me, is that point clear? Is that clear? That is why I'm taking a start node. If this is clear, please hit the like button, guys. Please hit the like if you are clear with this, right? So I will try to find this particular node. So let's say the target value is 7, and this is the particular node. So below this particular node, all, like, I have to, in if I find it, then after that what I should do is, what I should do after that, I should start from here, right? So below this node, every node that is having the same position as this node, they will be counted in my final sum that I'll be returning, right? So in such a case, I will say that, okay, once I will find it, so I'll mark it as the start node. Okay, and then I'll start a recursion from here. Okay, then I'll start a recursion from here. So I think this point is clear to everyone right here. All right, so in this case, that is why I've taken this node. Okay, so initially I'll mark the start as null. Okay, initially what I will do is I'll mark the start as null, indicating that, okay, there is nothing. Now I'll start this recursive call. Okay, or I can say it as find target. Okay, let's name it as find target. Find target. Let's say this is the function name. Okay, find target. This will sense better. Right, now what I will do is, it will be void recursive in nature. So find target, I'll pass this, and then I'll pass the root node. So I'll basically pass the root node. Then after that, I'll pass the target value, and I'll also pass the int position, right? Int position. Now, can I say that I also require the position of the target node, right? So I'll have a int variable that will store the position of the target node. So what should I say? Final position, like start position, I should say, right? Or I should say that target position, right? Let's name it as target position. So initially we will not initialize it, right? Now after this, what we will do is I'll start the traversal. Okay, so let's say if I'm starting the traversal of my tree, so what can be the circumstances? There can be many circumstances that can lie ahead, and the basic circumstance is that if the root is equal to null, okay, if I reach a particular node that is null, so in that case what will I do? If I'm finding, so I'll simply return what? I'll simply return from here, right? Otherwise, what can I do? Will you call in the left and the right both? What do you think, guys? Please tell me. Like, see, another thing is that, let's say if the root, if it happens that the root data, okay, if it happens that the root data is equal to the target data, right? If the root data is equal to the target data, in that case, what should I do? If the root data is equal to the target data, then I'll mark my start node as the current root node that I am at, okay, and I'll mark the target position. I'll mark the target position with the current position. Is that clear to everyone? Please tell me. Is this clear? If I find this particular, if I'm running a traversal in which I'm finding out this particular node, target node, node with the target value. So if I reach a particular node that is having the same data as the target, so in that case, this is the particular node that I wanted, and I will mark my start value as this root, and I'll say that okay, the target position, because I need to store its position also, right? So I'll mark the target position with the current position, and then I will simply return from it. Otherwise, what will you do? Will you call it? Will you call the recursion in the left direction as well as the right direction? Yes or no? Please tell me. Normally what we do is, if we have to find something inside this tree, then we will call for the left, we'll call for the right both. But do you think that we should call for the left and the right both? Yes or no? Please tell me, guys. Please tell me. Should you call in left and right both of the directions? I don't think so. Why you should not call in left and right both directions? No, we no need to call in both the directions. Yes, because if you will observe, let's say if I was at a particular node, right? Let's say what was, let's say what happened was my target node was, let's say something like 7, okay, and let's say this value was 5. Now this value will be 3. Let's say this value was, let's say something like 6, let's say, okay. So now if it happened that I was at currently this particular node, okay, so this was my current root node. If it is have, since this is a BST, okay, since this is a BST, so if this root node is having value lesser than the target, then I should search in the right side. Are you getting my point? Then I should search in the right side. So in that case, what I'll do is I'll simply check that if it happens that let's say the root data, okay, if it is lesser than let's say if it is lesser than the target value, then I should call the recursion, okay, I should call this find target function in the right side, okay, because I should, in that case, I should move to the right. Please write yes in the chat, okay. So I should move to the right child, RIGHT, root dot right, okay, and I should pass this target value, and I should pass this position as position plus 1, because I'm moving to the right side. Otherwise, if it happens, let's say that I am having this root data greater than the target value, okay. So if it happened, let's say that the scenario was something like this. Let's say if I was having this value as 9, so if the root value is having like if the root data is greater than the target, in that case I should move to the left, I should search in the left side. Please write left in the chat, guys, if everyone is clear till this point. Is everyone clear? So in that case, what I'll say is, I'll say that okay, let's call for the roots left, let's pass this target value, and now let's mark the position as position -1. Is that clear to everyone? Please tell me. This much point is clear? Okay. Kishan is saying yes. What about other people? If others are also clear, then guys, please make sure to hit the like button if you're clear till now. Okay. So this is what we will be doing. Right. Now, after that, when I come back, okay, when this recursive call is over, and let's say if it happens that my start node is still equal to null, because before the call I had initially marked it as null. So if it is still null, so this means that the target does not exist. Okay. Target, this means that node with, if the start is still null after the traversal, so this means that node with target value does not exist, right? Does not exist. So if it does not exist, in that case, what will I do? If it does not exist, then I should simply return nothing but -1 here, right? So in that case, I'll simply return nothing but -1 here. Is that clear to everyone? Instead of writing recursive function for finding, we can iterative, yes, I could have done it iteratively as well. You are right, I could have done it iteratively, but at the first instance I had written it using that format only, that is why. Okay, now in this case I need to have a total variable, right? So I'll mark the total variable initially as 0, because if it exists, right, otherwise if it exists then I'll mark my total as 0. So let's declare a total variable here as well. So let's say int total will be there, right? That will calculate the total sum, right? Let's say total sum. So let's name this as total sum. Just a second. Let's name this variable as total sum. Otherwise, I'll calculate the total sum of the nodes that are having the same position and below the starting node. Is that clear to everyone? Guys, please tell me. Is this much point clear to everyone? Recursive code is sweeter and short, yeah, but it is costly as well, definitely. So this much point is clear to everyone, right? Please give me a +1 if you are clear till this point, guys. Please give me a +1, then I'll proceed further. Okay. So otherwise, what I will do is I'll run the recursive call. Okay, I'll run the recursive call now, and I'll start from the starting node, like basically the node with the target value. From there, I'll start. Okay, and what will I do here, guys? Anyone can tell me? I'll start from there, and initially, if I'm starting from there, so I need to calculate the final sum for myself. Okay, so if I'm starting from there, so I'll say that okay, let's start from there, and in that case I will pass what? I will pass a variable that will be nothing but like target, or like let's pass this. So initially, what can I say? If I am passing, so in this function I need to pass the target value, right? So what can I pass? uh if I am having this position, right? So what should we do here? If it happens, let's say I'm passing the position, right? So let's say initially I'll pass the position. So initially it will be having the target pos, right? It will be at the, like initially I'll be starting from the target pos only, right? So in that case we will simply do what? We'll simply start. So it will be like kind of void recursive call. Okay, now I'll pass what? I'll pass this node star, and this will be the route that I'll be passing, current route that I am at. Okay, and I'll pass the int position. Okay, so basically I'll start from the current position. So you can say that int current position that I'll be starting from is the target position, right? Because I'm starting from the route, from the current start. So that is why I'm passing this as the current position. Is that clear to everyone? Please tell me, guys. Is it clear? Pos value of the target, yeah. Current position will be what? Like currently, if I had a tree like this, okay, so let's say if this was the guy that I want to start from, so the position will also be like initially the current position will also be equal to the target pos, right? The position of this guy will be the current position. Okay, is that clear, guys? So that is why I'm starting from here. Is it clear to everyone? Okay, now in this case I have this, so let's pass this as the current position. Okay, now what I will do here is I'll simply say that okay, if it happens that the current route that I reach, okay, if it is null, in that case I'll simply return away from here. Otherwise, what are the options that we have? Otherwise, let's say that if the current route that I am at, so if the current route data that I am at, if it is equal to the okay, no, in that case I need to check that okay, if it happens that the current position that I'm at, okay, if the current node that I'm at, okay, if the current node position is equal to the target node's position, okay, so it is vertically below, right? It is vertically what? Then this means that this node is vertically below. Yes or no? Take the sum. Take the sum. Is that clear to everyone or not? If it happens that the current node that I'm at, so if I'll show you here, let's say that this was the target node. Okay, let's say this was the target node. Now, after that, if I have this left child, right child, this child, then this child, then this child, then this child. So let's say the target, this guy's position was 0. Now, in that case, this will be -1, this will be 1. Okay, this will be -2, this will be 0, this will be 0, and this will be 1. So in that case, you can say that this is the current position. Okay, and this is also the current position. So let me draw it more properly here. Let's say this is the guy and this is another guy. So now if this happens and this is the target pos, right? So the target pos is what? Target pos, let's say, is 0 here. So in that case, you can understand that okay, here the current pos is also the same. So the nodes that are having the current pos same as the target pos, that they will have the same value. But we have calculated pos till target. Yes, we have calculated till target. So now that is why whenever I'm moving down from there, so I need to change their positions. Now, is that clear? So if this thing happens, in that case, what will you do? In that case, you will simply say that let's calculate the sum. So you'll say that okay, total plus is equal to the current root data. So root data. Okay, total plus is equal to root data. And yes, you have calculated. Okay. So in this case, you are saying that we will be calculating for the root also, na? Okay, so in that case, what we can do is we can say that okay, we can start from its left. Okay, if we are starting from its left, then we can pass the position as -1, and similarly, I can run a recursive call, and because I don't need to include that node also, yes, that is fine. So in that case, I can start from the left and the right nodes. Okay, because I don't need to include that node. So in that case, I can pass this as current position +1. Is that clear, guys? This point is clear. So that is one thing that we can change if we are starting. So basically we don't need to include the, because the target node will the current position if we are starting from here. So in that case we'll include it. So that is why we can we if we can simply skip it, right? So in that case we can simply call from this child and this child, the recursion from this child and this child, right? So I think this will make sense. We can use the queue for level order traversal. Yes, obviously code and code we can use the level order traversal. I hope that you are not the original code and code. Okay, fine, seems to be fine, right? Okay, so I think that will take care of the things, right? So now in this case I'll call the recursion. Okay, and for the current root, let's say I'll pass for its left child. Okay, and the current position will decrease by 1, and similarly I'll call the recursion. Okay, and for the current root node I'll pass for the right child, and then the current position will increase by 1. So this is what will happen. And after this traversal is over, so I think that I can simply return the total that I have, total sum that I have collected. So let's declare this as total sum as well. I think that will be fine. Is this point clear to everyone till now? Let's see how many mistakes we have made, because the code was quite large and the explanation was quite large as well. So yeah, comments. Right, let's remove the comments. We can use map. We can map all using, yes, we can do that also. Works on the samples. Let's try and compile it again. I think this solution is working on the samples. Let's see what will happen when I'll submit it. The queue is very intuitive. This question is very intuitive, definitely yes. Okay, so it gets accepted. Please give me a +1, guys, in the chat if everyone is clear with this question. Is everyone clear with this question till now? If you are clear, then please hit the like button as well. Okay, guys, please hit the like button if everyone is clear with this question. Is everyone clear with this question? Please hit the like button and give me a +1 in the chat if everyone is clear till now. Is everyone clear with this question? Okay, so code and code says that okay, this question is very intuitive. Can you share this code with us? Definitely yes, I can share this code, liked and all. Okay, just a second, I'll generate the link for this code as well. So let me do one thing. Let's go to this. Let's copy this here. Okay, let me generate this link. Has everyone understood this problem? Please hit the like button, guys, if you have. If you're someone new who's watching, so please hit the like button. Okay, so let's share this link as well. All right. So I hope that everyone was able to understand this problem properly, right? So basically, this was a two-step process. The very first step was to find the target node. Okay, find the target node that you will consider as the starting position, and from that, you like from that you will get the target position. Okay, and from that node, from that start node, below that, from the left and the right, you start the traversal, and whichever node then you start from that target node. Okay, from its left and the right, and whichever node has the current position equal to the target position, so they will be just vertically below the node. So all those you need to count, right? Is that clear to everyone? Please hit the like button, and within 30 seconds I'll end this stream as well. So is it clear? Any doubts? I hope that there is no doubt. All right, so this was it for today's video. Thanks a lot for joining, everyone. I'll see you in the next live on Wednesday. Till then, good night, take care. If you haven't liked the video, make sure to hit the like, and take care. Make sure to solve the problem of the day for today as well as tomorrow. So bye everyone, take care, and make sure to mention your feedbacks in the comment section. Thank you.